First of all, thanks to the organizers for the invitation. Second of all, I have to admit that I'm not sure this counts as digital humanities, but then I'm not entirely sure I know what the bounds of digital humanities are. But it's the end of the day, so I hope at least you'll find this amusing, if nothing else. But there is a more serious point here. So, unless you've not been paying attention at all to the news, you will know that there's been a lot of hype about large language models and general, so-called artificial general intelligence. But I'm a linguist by training, and my interest and the interest of other linguists in particular has been on what do large language models actually know about language? And there's been a whole bunch of work on this question, from various angles. I'm not going to have, time to summarize any of that stuff here today, but what I am going to do is sort of take a somewhat different take on looking into this question by asking the question of, large language models clearly know a lot about languages, so they know, well, in particular English, and to a lesser extent other languages as they get less and less frequently represented on the web. But how much do they know about language in kind of the abstract, or in particular linguistic variation, okay? So one way to probe this is to ask them to construct a new language. Okay, just make up a language, okay? Now, what do I mean by that? Well, of course, there's a whole field of constructed languages, which is often called conlangs for short. And, obviously, most famous example probably is Esperanto, which was actually made up to be a language that would substitute for a real language. And I believe there's about 1 million speakers of this language in the world, something like that. So it actually is used. But then maybe you're perhaps even more familiar with, if anyone's watched The Lord of the Rings, right? The Quenya, the Elvish language, is one example. So the Tolkien's languages, also in science fiction, Klingon, things like that. There's so-called logical languages. There's philosophical language. So maybe one of the most famous examples is the English philosopher John Wilkins, who created a philosophical language, as he called it, and so on and so forth. And there's a whole community of so-called conlangers. Now, I am not a member of this community, but I have, in my time, created languages. But just out of curiosity, how many people have made up their own language in this room? Don't be shy. Okay. Okay, well, okay, a few. Okay, cool. We have a paper out. So this was joint work with my intern from last summer, Chihiro Taguchi, who is at Notre Dame University. And we created the system. You can get the paper from arXiv, and you can also, if you want to play around with it or look at the outputs, you can look at, we have a GitHub site. The name is a little bit of a construct in itself. We made it the name Iasc, which happens to be the Irish Gaelic word for fish, when I work at Sakana, so which is fish in Japanese, so so it's kind of all fits together. Now, shortly before we put out this paper, there's another paper that came out that kind of got scooped, right? Somebody else had actually done similar work, and I was a little bit disappointed about this. But then I realized, well, okay, I tend to work on kind of weird stuff, and the fact that somebody else has also worked on this suggests maybe it's not that weird, and it's actually something sensible here. Okay, anyway, so what's the point? So we're basically going to use a large language model as an assistant to develop the phonotactics of the language. So for those of you in this audience who are not linguists, phonotactics means basically what words look like. So, you can have languages like Japanese, which have a fairly simple syllable structure, or you can have languages like Russian, which have an exceedingly complicated syllable structure, for example. Well, I'm going to skip that point. We then develop the morphosyntax of the language. Again, this just means, how the words are put together into sentences and how you change the words. So again, languages vary a lot. English doesn't have very much inflection. Korean, of course, has a great deal of inflection, and so on and so forth. And the way we do that is we're going to translate in stages from a source language original into the target language, okay? And I'll show you an instances of all of that. We then we'll actually use the phonotactics to fill out a lexicon. This is done kind of offline. It doesn't involve a large language model, although in principle it could be. We develop an orthography, Right now, this is based on an existing script, and I'll show you examples of that. And again, we use that to basically populate the lexicon with spellings of words. And then we write we actually have the system write a short grammatical treatise of the language, basically a couple of pages describing the language, okay? And have it make up a name for the language. You'll see that's kind of interesting in itself. And then so on and so forth, you can actually have it translate by adding morphemes to the lexicon. And, well, unfortunately it's covered here, but basically the point is we're particularly interested in these first three issues to see what the large language model understands about language, okay? Okay, so for example, I want a language that has Welsh-like phonotactics. Why Welsh? Well, I've been interested in Welsh for many years, and actually the CTO of our company is a Welsh native speaker, so that's two reasons, I guess. Syntax and inflectional morphology similar to that of Turkish, okay? An orthography that uses the Cyrillic script, so you can ask for these kinds of things. And some research questions, and this is really the important part. Can it indeed come up with a model that looks like the language I asked for? Okay. How well does it understand my instructions on how to create morphosyntactic features for the language? And how well, so how well does it understand each of these features? And how reasonable are the orthographic choices? And let's sort of start with the phonotactics here. So what we're going to do actually is this is what's termed these days an agentic system, where basically it's you prompt it to design a system saying, I want a language that has phonotactics similar to Welsh or Japanese or whatever. And this is going to give you basically a set of sounds, phonemes, and their nominal frequencies. So some sounds, of course, are more frequent in language than others, and so it gives you its sense of what the nominal frequencies are. And then it's going to produce Python code. This is something that language models are very good at these days. Had we had this 20 years ago, Professor Bach would not have needed me to teach him, and we could have just had a large language model do it. Then it's going to look at its code and its outputs, and it can say, okay, is there anything wrong with this? Maybe the code doesn't run at all in some cases, but even if it does run, it may produce outputs which are not, quite right. Then it can revise the code, and so go around in this loop, and eventually at the bottom here, again, it's covered, but basically you'll get a model, a Python program that you can run and actually have it produce words. Okay, so here's an example. Now, I realize probably nobody else in the audience knows anything about Welsh, but one thing I'll tell you about Welsh is that this is a set of the consonants, okay? And one of the most characteristics features of the Welsh language is this so-called lateral fricative phoneme. So, for example, the word for library is llyfrgell. Okay, so those ll and the end, that's a very distinctive sound in Welsh. And it was missing this is, by the way, using Claude, the Anthropic system, the Claude Sonnet 3.5. This was actually missing it on the first iteration, but on the second iteration, it said, it realized it was missing it and picked it up, okay? So I thought it was kind of cute. I mean, it sort of realized that it made a mistake, and it sort of has some sense about, Welsh phonotactics. Okay, so this is all very cute and everything, but how do you evaluate this? So what I did is we took about 50 languages from Wiktionary, which have IPA, International Phonetic Alphabet, transcriptions in the lexicon. We use these to build a traditional old-style n-gram language model, which turns out to be, traditionally is being used. It's quite good at, say, detecting, is this English or is this Dutch based on letter frequencies. That's a very common technique. And so, the closer it, depending upon the distribution of the letters or the sounds in this case, you can say it's closer to English or it's closer to, Welsh or whatever. And then you generate, you use the grammar to generate, say 10,000 morphemes, and you compute the perplexity, which is just basically a measure of how similar it is. The lower the perplexity, the more similar the two things are. And, if it did it well, then, it should be most similar to that language and not to some other language, okay? So there is a caveat here, and that is that Wiktionary has a very, very, I don't know if anybody's looked at Wiktionary from, for different languages, and their how they represent sounds, of the language. But there's a great deal of, great distribution in how fine-grained the transcriptions are. So, for example, for Japanese, if you take the word "laigetsu" in Japanese, the way that appears in Wiktionary is on the left here. So, this is how it appears in Wiktionary. This is a very, very fine-grained phonetic transcription. Whereas over here is sort of more at the level of what you might get from the large language model. Okay, so how did it do? Well, I mean, there's still work to be done here. But it is interesting, there's actually, between the language models that we compare, there is a difference. So Claude gets actually 4 out of 10 languages. So on the left is the target language. I want a language like English, I want a language like French, I want a language like German, so on and so forth. On the next columns are the languages that it was most similar to in this set. Okay, so in the case of the top one, say, most of them got them as most similar to English, although for some reason Lama got it as most similar to ancient Greek. I have no idea why. Also, Turkish seems to be a common confusion for reasons I don't understand. And then you can ask also how often, okay, maybe it's not the top one, but how often is it in the top 10? And again, Claude is somewhat better. So, Claude is in the top 10 or at least in the top 10 for 5 out of 10. So there's clearly a lot of work to be done. But to be fair, this is actually not an easy task, right? Because basically, if I asked a phonetician who knows Python, write me a program to generate a language similar to that, it would be hard for them to get it exactly right. But what this suggests is that at least they know, something about some languages. Okay, so there's some coverage there. Okay, let's move right on. So basically, I mentioned earlier that we basically build up a morphosyntactic annotation starting from a source language, and the source language in all of our experiments was English. It doesn't have to be English. But we, just for convenience, we used English as the starting point. And we had a set of 45 grammatically balanced English sentences. What I mean by grammatically balanced is that they are trying to cover the kind of phenomena that in some language might be marked in some way. Okay, now hopefully this will become clear. So you start with word order, for example, and you prompt the model to transform the English sentence into the target order. And then for each syntactic feature, you prompt the model to annotate the sentence with that feature. So basically, you're building up annotations, okay, on the sentences, okay? And we instructed not to remove any annotations that it had done on the previous phase. Unfortunately, it doesn't always follow that instruction. Sometimes it drops stuff, so that happens. We also ask it to lemmatize, that is, put the words into their sort of dictionary form. Words like, dogs would become dog, for example. The reason we do that is because we don't want, at the end of the day, we want dog to be one particular word, one word in the target language. And if that target language inflects, then it would also add those inflections of the word dog. But we don't want dog and dogs being confused, right? Again, we'll see that that doesn't always work either, quite. So here's an example. I want to take English and convert it into Turkish-like syntax. So for example, one of the things of Turkish is like Korean, like Japanese, it's verb final. So it's the first thing it does is it moves to the verb to the end. That works so far, so good. Turkish has a negative marker on verbs. So you can see here that it's adding, the negative marker. Turkish also marks case, unlike English, so it adds a nominative case, so subject case, and accusative case, object case to the words, and so on and so forth. Or let's say I want to go to Arabic-like syntax. So in standard Arabic, at least, has verb initial order, so it's a VSO, verb subject object language, and it also marks case. Okay. So we had a bunch of languages. So when I say, when I talk about a language like Welsh or Turkish, I'm not actually talking about Welsh or Turkish. I'm talking about a set of a language that has features like that language, okay? So this is like Welsh-like syntax would have, for example, a bunch of different features, but in particular, the main thing here is the verb, subject, object order, okay? Or this language, Ishkarayana, I'm going to see what translation does with the Ishkarayana down here. Very curious. I don't see it. Oh well. If it shows up, Oh, there we go. Oh, it didn't. Okay, well, fair enough. It didn't try. Okay, so anyway, so it has OVS word order, which is very unusual. It also has an inclusive-exclusive distinction. So that's, unfortunately, neither English nor Korean has that. So when you say we in English or uri in Korean, you don't know whether you're talking about yourself including the hearer or not. But there are languages that make that distinction. Okay? So, Mizo, another language that we included, OSV order, very unusual. It also has ergative absolutive marking. Okay, so that means, you know, if John saw Mary, the John is the subject of a transitive sentence. There's an object there too, so John would be marked in the ergative case. But if John left, John would be marked in the absolutive case because that's an intransitive sentence. Okay, and then we had a hard feature set, what we called hard, which was basically a collection of different features that are unusual, like OSV order, ergative absolutive case marking, prefixing case, that's exceedingly rare in world's languages. Adjective agreement strategy also was prefixing. Nominal number is singular, plural, and dual. I mean, most of these features can occur in some language, but the collection of all of these together is a little bit unusual, or quite unusual. Okay, so how do you evaluate this? So what we did is we took our 45 sentences and we actually had 9 language configurations, including that hard language, okay? And we basically by hand, this was a fair amount of work, this was what Chihiro spent a lot of time doing, was basically annotating the target of what we expected the system should produce. And obviously there's some wiggle room here, but the point is we should, if you ask for verb, if we ask for Turkish-like syntax, you at least expect to get the verb at the end of the sentence, okay? And you at least expect to get, certain kinds of case marking on nouns and so on and so forth. Okay, so how do you evaluate the results? Well, there's a whole bunch of different measures. I'm not going to go into them. I'll just highlight one, basically, this morphosyntactic error rate, which is a combination of 2 things, which is what we call the stem error rate. That simply forgets any of the things you might add to the words and simply looks at their overall order to make sure that they got it basically in the right order. If nouns are supposed to occur before adjectives, then the noun should occur before the adjective and not the other way around. And then the morphological feature rate is, well, ignoring the possible errors in syntax, does it at least mark the features you asked for? If it asks for an ergative absolutive case marking system, do you get an ergative absolutive case marking system? Okay, and they're also unfortunately obscured at the bottom here, but basically there's this kind of a lemma error rate, which is how often it does the lemmatization correctly that I mentioned earlier. Okay, so how do we look? Okay, so I'm going to have to tell you what these languages are because you cannot see it. So this is Arabic-like, this is Fijian-like. I'll put at the top, by the way, what the word orders of these target languages would be. This is French-like, this is Ishkariana-like, this is Mizo-like, this is Turkish, Vietnamese, sorry, I got off one, Vietnamese, Welsh, and the hard set, okay? And you can see it's kind of across the board. The main point is lower is better, okay? Because we're talking about error rate here, right? But one of the things that seems to be true, by and large, is that you get things like VSO or SVO or SOV order. Well, Turkish seems to be kind of an exception to this, but generally speaking, those kinds of word orders work okay, whereas unusual orders like VOS or OSV tend to be less well covered. Okay, this again mixes both the syntax and the sort of morphological inflection, so it's a little hard to see what I just said. But one thing you can see is that when you can sort of combine a whole bunch of hard features together, things generally look worse. There is, again, a lot of variation among the different language models. So it's a kind of messy plot, but I mean, it does show that there's a great deal of variation, and that, by and large, things that are harder, that is, things that occur less often in the world's languages, seem to be less well represented. Okay. quickly on orthography, this is just to give you an example. It's sort of like the phonology one, but basically now you're asking it to come up with how do you spell these things. So this is like a Welsh-like phonotactics using Cyrillic orthography. I'll just point out one feature which I found kind of cute, which was, how do I go back here? Is there a back button? Sorry. Left one. Ah, there we go. So unfortunately you can't see the thing there, but basically this is an extended Cyrillic letter that is actually used for the Chukchi language, which is a Siberian Kamchatkan language, where they actually have this sound, the hl. And I didn't even know this. I learned this from Claude. So I didn't know that this extended symbol exists. It doesn't surprise me, but anyway. Then, just briefly, writing the handbook, right? We have it. We present a bunch of features of the language. We give it some examples. We give it an example of the lexicon and so forth, and we ask it to then produce basically a breakdown according to a certain structure. We ask it to talk about the phonology, orthography, morphosyntax, and basically, as I mentioned before, to invent a name for the language. Okay. So here's one example. Here's a language called Ku-Kadh. And it is a Japanese-like language with a Cyrillic script and Ishkarayana-like syntax, which is, again, OVS, right? Well, it describes it. It likes to make comments like, this orthography is simple. Well, actually, they're all simple because they're basically very simple segmental orthography. It mentions the fact that there's an inclusive exclusive, which is correct. It mentions the fact that it's supposed to be OVS, but unfortunately, well, you can't see the example again here, but it turns out it's not OVS because the verb is actually not in the middle. It's actually, they put it at the end. So this is an example. If you ask for an OVS order, you tend to get the verb at the end because OVS is really, really weird, right? It's just not many languages have it. Anyway, moving right along, here's a sample of the lexicon. Okay, one of the kind of the cool things is the the names for the languages. I'll just go through this very briefly. When it's for the Latin script, these names often look like things out of fantasy fiction and stuff like that. At least to my sensibilities, right? If you go down to Arabic, these look vaguely, Middle Eastern, kind of that kind of sort of word. If you go down to Cyrillic, well, sometimes they're kind of boring, like Cyrillic ergative. I don't know, that's kind of a silly name, or Kyrillic. But sometimes they look sort of Central Asian and so forth. Whereas Greek tends to look, well, you got silly words, names like neosyllabic and neolexical. These are all names that the language model's made up, okay? There's kind of I think it kind of makes sense. The Latin script is the most widely used script in the world, so it doesn't really bound to any particular geographical area in the modern world. The Arabic script, on the other hand, is much more localized, although it is widely used. It's, basically in much of the Muslim world. It's also used in, in Muslim world, including North Africa and Middle East and, a little bit into Central Asia. Cyrillic is used widely by languages, particularly of languages of the former Soviet Union. So it's a wide area from Central Asia all the way to East Asia, whereas Greek is only used for Greek. I mean, it could have been used for other languages, but it really is only used for Greek. So I'm sure everybody here is wondering, but, what if I did it for Hangul? So the answer is, well, it kind of doesn't look that good, unfortunately. I actually tried giving it full Hangul syllables as a way to do it, so that didn't work at all, really. So I ended up asking for having it do jamo, so the basic, components of the syllable. And these, well, you can kind of see it sometimes try to combine things into syllables, but it doesn't look very nice. So, this is something, unfortunately, Hangul is not easy to adapt, and it, in fact, has only been, as far as I know, adapted to one other language besides Korean. That's the Jia language of Jia language or whatever of Indonesia. There's just one language to which Hangul has been adapted. Anyway, so we can also get it to translate. These are actually large language model generated stories where it's translated a language with the dual, and notice that, it actually correctly translates dual as, both towers should come out as dual, which indeed it does. Okay, takeaway points, summing up here. What do large language models know about language? Well, the knowledge of phonotactics is obviously imperfect, but there is a clear difference between different large language models. On balance, I would say that the Anthropic models seem to do better at these kinds of tasks, and that also applies broadly to the morphosyntax for whatever reason. All of the models struggled with the so-called hard morphosyntactic combinations. Okay, so generally asking for things like unusual combinations of case prefixes, it almost never gets right, as it turns out. Even though it's kind of easy to describe, but somehow it doesn't want to do it. Less common word orders tend to be problematic. Okay, models are instructed to lemmatise English, but for some odd reason. This actually is harder for the models if the target language is less complex, is more analytic. So a language like Vietnamese, or target language with Vietnamese-like characteristics, I should say, it doesn't do as well. And this was actually significant across all the language models we tested. And generally, I would say the results are not surprising, but they kind of point to a couple of things. First of all, obviously, large language models, they know a lot about language, but they're not all knowing, right? They're not yet good substitutes for a linguist. If I told a linguist, create me a language with case prefixes, I think they could do it fairly consistently, right? Whereas the large language models seem not to be able to do it. At least we weren't able to get them to. They are very powerful pattern matching models. I don't think they're, some of you may have heard this phrase stochastic parrots that became popular a few years ago by Emily Bender and others, right? I don't think that's quite an accurate characterization. On the other hand, I don't think you could argue that they haven't really internalized general linguistic knowledge at a sort of a deep level. Okay, there's obvious limitations. I think many of you, all of you have probably realized at least some of these. Obviously, translation from English is not necessarily the best way to go about this. The best you're going to get is translationese. Phonology is obviously more than phonotactics. We actually have a phonological change model, but it's sort of integrated into the whole system. Morphology is obviously more than just suffixes and prefixes. Also, morphemes are always generated with single forms, so that would be pretty good for a language like Korean, where most of the time the morphemes, if you want a plural suffix, for example, it's going to be the same thing. But obviously, languages like Russian or Spanish or Catalan or whatever, they have much more complex morphology than that. Features like gender, number classifier systems, those are going to be problematic. Actually, it's not clear how you'd even do gender, right? Because, if I'm starting with English, what would I decided, let's say it had masculine, feminine, and neuter gender, how would it decide to assign gender to a given word? Orthography is limited to simple segmental writing systems using existing scripts. And obviously, actually one of the kind of striking features of conlangs in, say, fantasy fiction, like, say, The Lord of the Rings, is probably nobody has any clue about what they're babbling about when they're speaking Elvish, but you have a good visual image of the so-called runes, right? So we'd like to actually have it be able to create new symbol systems. That's sort of a research project in itself, and so on and so forth. So with that, I will just leave you with the fact we have, as I said, the GitHub repository if you're interested, and also the archive paper on archive. And good.
Thank you. Let's give him applause.